Limiting reactant video. What I'm going to do is set up two different videos, about 5 minutes each, one with limiting reactants and the next one with percent yield. So check them both out. Anyway, the limiting reactants, it's all about what's used up first. Whatever reactant is used up first, that is the one that will determine how far the reaction will go, how many products you can produce, how much of the excess reactant you will use up. So here, what I want to do is do a quick analogy. Let's say I have 25 boys and I have 27 girls, okay? And what I want to do is make couples, okay? So the product is boy-girl couples, okay? And so what I'm going to do is react these two together and then see what I come up with. Well, obviously, if I'm going to make 25 and 27, if I'm going to make couples out of those numbers, it looks like that I have less boys than girls. I have two less boys, so therefore the boys will dictate how many couples I'll have. And I think we can say that I'll have 25 total couples once everything's all said and done. And we can probably figure out that there are going to be two girls that are left over that are unreacted or whatever. Anyway, the boys limit my reaction to 25 couples. I completely use up the boys. This is my limiting reactant. The girls, I have too many of them. That's my excess reactant. That's a quick explanation of limiting reactants. So what I want to do is let's go into a problem here. It says I have 3.5 grams of sodium reacts with 1.25 grams of aluminum chloride in a single displacement reaction. And it says in A, what is the limiting reactant? So let's do that right away. All right, I have two different numbers here. Let's write those down. 3.50 grams of sodium, and I have 1.25 grams of aluminum chloride. Okay? What I should have done first is write my balanced equation. So I have Na plus AlCl3 yields, and this is a single displacement reaction, so sodium will take the place of aluminum, and aluminum will be alone. And to balance this, I need a 3 here, and I need a 3 here. Okay? So what I need to do is stoichiometry. And often I've told you guys that limiting reactant problems or excess problems are just applied stoichiometry. So what I'm going to do is convert both of these to moles, which is the second step of stoichiometry. This is 23 grams of sodium, and this is 133.5 grams of AlCl3. So that's 1 mole of AlCl3, and this is 1 mole of sodium. Sorry, it's so sloppy. My computer's running slow. And then, of course, I need to compare it to the same product. Okay? I am going to choose, well, I have a choice. I could either use sodium chloride or aluminum. Now, either one that I pick, it doesn't matter. I'll get the same result. But maybe I can shave off a little bit of time and work later. So I look in letter B. It says what mass of sodium chloride is produced. Well, there's sodium chloride right there. I'm going to choose that product, and that's going to shave down some time later. So mole ratio says I have 3 moles of Na on the bottom, and I have 1 mole of AlCl3 on top. And I'm going to convert it to the exact same product. And notice I have 3 moles of NaCl and 3 moles of NaCl. So the green color shows that I am converting to the same product. Okay, and I got kind of tight here, so I'm going to try and squeeze this in. So when I get out my calculator, I will take 3.5 divided by 23, hit equals, times 3 divided by 3. That gives me 0.152. Let me write it in black. That gives me 0.152 moles of product. Okay, 0.152 from there. And then down here, I have 1.25 divided by 133.5 times 3. Let me do that again. 1.25 divided by 133.5 times 3 gives me 0.0281. So this is 0.0281 moles of product NaCl. Okay, so when I look at these two circle writings in black here, it looks like that my 1.25 moles of AlCl3 is my limiting reactant. Now why? I produced less product here. The reactant that produces less product is the limiting reactant. This one is in excess, so I'm going to ignore it. And I really don't need to do any calculations with that again. Okay, so letter B, we answered the question, what is the limiting reactant? We will call it AlCl3. Letter B. Let me erase this and make some room. Okay, letter B says, what is the mass of sodium chloride? Well, we started off, we ended with 0.0281 moles of NaCl. So all I got to do now is convert to mass. This is step 4 of stoichiometry. 1 mole of NaCl, I'm back to 1 mole again, is equal to 58.5 grams per mole. So when I take 0.0281 times 58.5, I end up with 1.64 grams of NaCl produced. Okay? That is part B. So that was solving for the mass of a product using the limiting reactant. Letter C. Okay. In letter C, I have, it says how much excess reactant is left after the reaction, okay? So again, I have my limiting reactant, we know is AlCl, so it's AlCl3. 1.25 grams of AlCl3 again is the limiting reactant. So I'm going to take that again through the steps of stoichiometry. AlCl3, 1 mole of AlCl3. And now I'm in the mole ratio. But now instead of converting to a product, I am going to convert, see, this is the limiting reactant here. I'm going to convert to this. This one is the excess reactant. And that one I have too much of. So I want to find out how much I actually use considering the quantity of the limiting reactant. So 3 moles of Na. Now I can't do much with moles. There's no mole balances, so I better convert it one more step. 1 mole of Na, and on top is 23.0 grams of Na. Okay, sorry about it's running off the edge there. All right, so take your 1.25 divided by 133.5, hit equals. Multiply by 3, hit equals. And then multiply by 23, hit equals. I actually only used 0.640 grams of Na. That's how much I actually used. Okay, so if the question in letter C says how much did you actually use, how much excess reactant, sodium, you could answer correctly and say 0.64. However, the question says how much excess reactant is left after the reaction. So I was given a whopping 3.50 grams of sodium, but I only actually used 0.64. So I'm going to subtract them. So 3.5 minus 0.64 gives me 2.86 grams of sodium left over after the reaction. Quite a bit left over. Okay? You got any questions about this? Make sure you see me.